Welcome back to the deep dive. Okay, so with Halloween just around the corner, we thought it was the perfect time to delve into something a little macabre, but definitely fascinating from a scientific perspective.
Absolutely. We're looking at what happens to a body when it's submerged in water, but not just the usual decomposition process.
Oh, we're talking about the specific, maybe even spooky creatures that get involved and how they can seriously complicate things for forensic investigators.
Exactly. Today we're doing a deep dive into a really interesting paper from 2019 by Pascali and colleagues. The title is The Red Swamp Crayfish Procambarus clarkii, the Louisiana Crayfish, as a particular scavenger on a human corpse.
Okay, so let's lay out the mission for you, our listener. We want to explore how this one specific invasive species is actually creating major headaches in forensic pathology.
Yeah, because it causes damage, postmortem artifacts that look surprisingly like injuries from, say, a knife attack.
And this paper was a big deal because it was apparently the first published report looking at the specific crayfish activity on an actual human body, right?
That's the crux of it. It highlights how something seemingly ecological and invasive species spreading can directly impact forensic interpretation. It can create evidence that might send an investigation down a completely wrong path, a real potential pitfall.
Okay, let's get into the specifics. The paper centers on a case study. Tell us about that.
Right, so the case involved an 85-year-old man. He was found deceased, floating in an irrigation ditch near Padua in Italy.
And how long had he been missing?
He'd been missing for 18 days before he was discovered.
18 days. And the environment that's crucial here too, isn't it?
Definitely. This was found at the end of summer, in September. The water temperature was recorded at around 24 degrees Celsius.
So pretty warm water.
Very warm. And those conditions, the warmth, the long submersion time they create, well, perfect conditions for rapid decomposition, but also for high activity levels of the main scavenger they identified in this case.
Which brings us to the culprit, Procambarus clarkii. The red swamp crayfish, also known as the Louisiana crayfish,
That's the one.
sounds almost common, maybe even something people eat. But ecologically, it's a different story.
Oh, a huge story. It's actually only native to parts of northern Mexico and the southern U.S.
So how did it end up causing problems in an irrigation ditch in Italy?
Well, it was introduced deliberately,
Hmm.
brought into Europe, including Italy back in the 1990s, mainly for commercial aquaculture, for farming.
Ah, and I think I know where this is going. It didn't stay on the farms, did it?
Nope. Predictably, it escaped. And once it got into the wild, into the inland water systems, it just exploded.
So it became invasive.
Massively invasive. It's now officially classified as an infesting animal right across Italy. It's taken over rivers, swamps, even sewers. And it often pushes out the native European crayfish species, which just aren't as robust.
Wow. So it's a known ecological problem.
A big one. It spread so widely that the European community actually monitors its diffusion.
Mm-hmm.
So ironic, really, the commercial interest that brought it there is now creating these forensic challenges.
What makes it so successful?
Yeah.
Why is it turning up on a human body?
Adaptability, basically. Its natural diet is carnivorous things like insect larvae, tadpoles, small snails. But it's incredibly opportunistic. Meaning if its usual food isn't around, it switches gears very effectively. It'll feed on dead animals, worms, detritus,
Yeah.
whatever's available. And it's tough. Grows relatively large, up to about 12, maybe 13 centimeters, and reproduces quickly.
So it can dominate a new environment quite fast.
Exactly. And when a large stationary food source, like unfortunately a human body, enters its habitat, it goes down on it.
Okay, that sets the scene perfectly. Let's move into the second part, decoding the actual injuries found on this gentleman's body. After 18 days in warm water, what did the body look like initially?
Well, as you'd expect, there were clear signs of advanced decomposition due to submersion.
Mm-hmm.
Autolysis, putrefaction were well underway. Parts exposed to air were drying out. And that classic washerwoman appearance on the hands and soles of the feet, pale, wrinkled skin.
Standard signs for that length of time in water.
Pretty standard, yes. But then there were the injuries linked to the crayfish.
And how certain were they it was this crayfish? Was the evidence clear?
Oh, very clear. They found 10 crayfish specimens directly associated with the body. 3 actually fell off the body as it was being recovered.
Right there at the scene.
Yep. 3 more were seen moving around nearby in the water. And crucially, 1 was spotted inside a significant wound, a substance defect, on the man's lower back while still at the scene.
Inside the wound itself.
Mm-hmm. And then during the autopsy, they found 3 more specimens inside the trunk cavity.
Inside the torso.
Inside the torso. So these weren't just nibbling on the surface. They were actively getting inside.
That's pretty definitive. Okay, let's talk about the external damage first, because this is where that potential for forensic confusion really comes in. What did they find?
The facial injuries were particularly severe. The report describes large substance defects, basically. Tissue was missing. The lips and chin were gone, exposing parts of the jawbone underneath.
How large are we talking?
The main facial defect was measured at about 9 by 9 centimeters. That's a substantial area. And the edges were described as irregular and partly jagged.
9 centimeters. That alone would raise flags for any investigator. Were there other specific marks?
Yes, they noted some specific linear lacerations about 2 centimeters long on the forehead. But it was the margins of the large defects that were particularly interesting.
How so?
They observed distinct incisures, little cuts or slits about 2 centimeters long, right along the edges of where the tissue was missing. And the authors proposed that these marks actually match the imprint of the crayfish's pincers, its chelae pinching and tearing at the tissue.
Okay, hold on. Linear lacerations, incise margins. If I'm an investigator and I hear those terms, my mind immediately jumps to, well, sharp force trauma. A knife.
Exactly. That is precisely the problem. The crayfish's pincers are strong. They don't just nibble, they pinch, they tear. And this action can create marks, these linear cuts, these jagged but sometimes quite defined edges that, especially on decomposing waterlogged tissue, can look alarmingly similar to cuts made by a blade.
So an investigator could easily mistake scavenging activity for evidence of an assault.
Potentially, yes.
Yeah.
If you focus just on the shape of those margin injuries and don't consider the broader context, the massive tissue loss, the environment, the likely scavengers, you could easily misinterpret postmortem scavenging as antemortem or paramortem violence, or at least it introduces significant doubt.
That's a serious complication. And you mentioned they found crayfish inside the body. What did the internal autopsy reveal?
That was perhaps even more startling. When they opened the trunk cavity, they found, well, a massive internal defect. Most of the thoracic and abdominal organs were simply gone.
The internal organs were missing.
It's largely absent, yes. Basically, the crayfish had hollowed out a significant portion of the body cavity from the inside. This really showed the scale of their activity and explained why those specimens were found deep inside the trunk. They weren't just surface feeders, they were excavators.
Incredible. So, given how misleading these injuries can be, how vital is it for forensic teams to specifically document and recognize P. clarkii wound patterns?
It's absolutely crucial. This paper really underscores that. Knowing the typical patterns left by local animal scavengers, terrestrial or aquatic, is fundamental to distinguishing postmortem artifacts from injuries that happened around the time of death.
Could this crayfish activity potentially hide actual wounds? Like, could a real stab wound be obscured by all this scavenging?
That's certainly a possibility, or at least make interpretation much harder. In this specific case, they identified P. clarkii as the main scavenger based on, well, its known feeding habits on large carcasses, the sheer scale of the tissue loss, its ability to feed on the bottom where the body likely rested initially, and the absence of other large predators in that ditch. Forensic teams working in areas where this crayfish is common now need to be trained to spot the difference between pincer marks and true sharp force injuries.
Okay, let's shift gears slightly to another major forensic challenge. Estimating the time since death, the postmortem interval, or PMI. On land, insects are key for this. But in water?
Yeah, in aquatic environments, PMI estimation is notoriously difficult. The insects we rely on heavily in terrestrial forensics often aren't present or behave differently, so crustaceans haven't generally been seen as very useful for PMI.
But does this case maybe offer a new possibility? Could crayfish activity help?
It definitely suggests a potential avenue, which is exciting because we really need better tools for aquatic PMI. The authors point to some earlier research, specifically a study by Montisci and colleagues, that used pig carcasses in water.
What did that study find about crayfish?
It identified two main stages of how crayfish colonize a submerged carcass. And critically, it found that the really intense feeding, the kind that causes these big mass defects we saw in the human case, tends to happen when the body has sunk and is resting on the bottom.
And they could time that phase?
Roughly, yes. The results suggested this rapid feeding phase typically occurred between 7 and 10 days after the pig carcass was placed in the water. That gives us a potential time window associated with a specific type of damage.
Okay, so back to the 85-year-old man. He was missing for 18 days. How does the crayfish damage fit with that timeline in the Montisci study?
It fits quite well, actually. The extreme level of tissue destruction, the missing face parts, the absent internal organs is very consistent with that known rapid feeding phase of P. clarkii having been active for a significant portion of those 18 days, especially given the warm water speeding everything up.
So understanding how P. clarkii colonizes and feeds could potentially become a tool for estimating PMI in water.
That's the hope. It suggests that if we can gather more data on their colonization dynamics, feeding rates at different temperatures, population densities, and so on, P. clarkii activity might eventually give us some reliable time markers in aquatic cases. It could help fill a major gap where forensic entomology often can't.
That would be a significant step forward. But let's apply some critical thinking, as the authors themselves did. Could they be absolutely certain that the crayfish were the only animals involved, or the first ones on the scene?
No, they couldn't be completely certain, and they acknowledged that limitation clearly in the paper. Given how decomposed the body was after 18 days, they couldn't rule out the possibility of synergistic activity.
Meaning other creatures might have played a role too.
Exactly. It's possible that smaller animals, maybe small fish, rodents, if parts were near the bank, or even other smaller crustacean species, could have created initial wounds or openings.
Like creating access points.
Precisely. Especially via natural openings like the mouth or nose, which smaller critters are known to use. These initial breaches might then have allowed the larger, more destructive P. clarkii easier access to get inside and cause that massive internal damage.
Kind of decomposition tag team.
Sort of, yeah. However, the authors argue that the sheer scale and type of the major defects, those really large areas of missing tissue, strongly point to the red swamp crayfish as being the primary driver of the most dramatic changes observed on the body.
Okay, so pulling it all together, what's the main takeaway here for forensic science?
The big message is that investigators absolutely must consider the potential for dramatic body modification by common invasive species like P. clarkii, especially when recovering bodies from freshwater environments where this crayfish is known to live, which includes large parts of southern Europe and other regions now. It has to be part of the standard assessment.
It adds another layer of complexity to interpreting evidence found in water.
It really does. And connecting it to the bigger picture, this case is a stark reminder that invasive species aren't just an ecological or economic issue. They can actively alter the forensic landscape, change the evidence itself, which demands that investigators constantly update their knowledge and methods. This is a forensic problem, basically created by human actions, introducing a non-native species.
It's quite unsettling, isn't it, that altering an ecosystem can directly lead to misinterpreting forensic evidence, which brings us to a final thought, something for you, the listener, to perhaps think about. If this one common invasive crayfish in freshwater can mimic sharp force trauma and significantly alter a body, how many other non-native species, maybe in different environments, forests, deserts, maybe even urban settings, could be causing similar post-mortem artifacts that we just haven't recognized yet, artifacts that might currently be misinterpreted?
That is a really important question. A challenge for future forensic research, definitely something scientists will need to dig into.
Indeed. Well, that brings us to the end of this deep dive. Thank you for joining us.